some moments. Okay, we are live. That's perfect. And yes, I hope you see my screen right. Perfect. So let's get started. So good evening, good evening, good afternoon, everyone. Welcome to today's session on retrieval augmented generation systems with Microsoft Fabric. And my name is Ilgar Zarbaliev. I'm honored to host this Power BI meetup, Power BI related meetup on June 13th, 2025. So today's session will offer solutions using AI and Microsoft Fabric to structure conversational data into useful insights. And I hope actually Alexandra will demonstrate how to use Microsoft Fabric, how Microsoft Fabric will act as the backbone to process and power this workflow, enabling large language models to perform at scale. So a little bit about our speaker. I'm thrilled to introduce today's guest speaker, Alexandra Savelieva. She is PhD and who is principal applied AI engineer at Microsoft. Alexandra brings 14 years of experience blending academic and industrial expertise across AI and IoT and investment banking technologies. And in her current role, she wears many hats as an engineer, data scientist, researcher, and project lead. I hope she will give the necessary info about herself. So, a little bit about our upcoming speaker. As I mentioned in the beginning of our session, um, this year I'm only inviting Microsoft speakers, Microsoft employees, and our next speaker is Miguel Myers, who is dealing with Power BI. And the next event is going to be happen in on July 25th. So a little bit about meetup rules. This meetup is lively streaming. You can type your questions while our speaker will demonstrate. Actually, at the end of the session, we'll have a Q&A, session for 10 or 15 minutes, so you can also ask a question there. If there is any material that's subject to sharing, I will share them with pleasure. A little bit about the schedule of our session. Now I'm making the first part of our session, like introduction. And I hope the next 40 or 45 minutes, Alexandra will demonstrate, will talk. And as I mentioned a little bit earlier, at the end, we'll have Q&A session, but you can type once again your question during the session. And here you can see my email address. It's zarbali@excelworld.org. This is my number. If you want to be speaker on behalf of Azerbaijan Power BI and Fabric Community Meetup Group, so please write me an email and I will take it into my deepest consideration. Now I would like to leave stage to Alexandra. Alexandra, I'm stopping. I stop sharing and stage is yours. Please share your screen and go on. Good luck.
Great. Thank you, Ilgar, and pleasure to meet you all. So today we are gonna go through an interesting journey together in the world of AI, and let me try to arrange it. So hope this is not too much in the way. This way I'll see if you raise hands, but in case you need to ask some urgent questions, feel free to interrupt. This is preliminary rough agenda for today. So we are gonna start with some fundamentals of building a RAG in general. And after that, we will go to the gist of the topic outlined in the title of today's presentation, how you build not just some RAG, but a RAG that is built on top of an adaptive enterprise knowledge base. And I'll share the pieces of secret sauce that help you accomplish this goal in an automated and reliable fashion. So Elgar has introduced me already. I won't stop here very much, except that I can highlight additional part of my personality. I'm a watercolor artist very actively, in addition to my GenAI job. And
I'm sorry, I forget about it. Sorry.
that's so
You
important.
you have very good paintings. Sorry.
Thank you. Okay, so why fabric is a big theme these days? Formerly, I used to be a full-time data scientist and data science lead, and at that time, there were many problems which we were able to solve on our developer machines, even laptops. And the trend these days is that problems are becoming more complicated and larger scale, while actual methods that you use, interestingly, largely remain the same. And so I look at Fabric as the new data scientist computer, where you still have a notebook in the middle, but to make things work, you have a unified storage layer, Lakehouse, a distributed compute platform like Spark, GenAI to help you accomplish things on data which were not possible before. And you can connect to other services in Azure or elsewhere to make additional things possible. Like here I'm outlining Azure AI Search because this is how you can build a RAG, but you can imagine other things. Okay. And a side note about how you can approach scaling up in the world of Gen AI. It no longer really makes sense to become super expert in a particular language or model because they just change too fast and it's not feasible to keep up. What I highly recommend to do is that you focus on general patterns and practices that allow you to select the right components for solving business problems, and then how you glue those components together in a reliable way. And then this will be your skill agnostic of a particular technology, and it will stay relevant in time for years, regardless of how crazy the technology changes over time. And that's also what we're going to do in this presentation. So starting with RAG 101. Theory, main concept. I'll walk you through basics of building a RAG with a node example, and I'll walk you through evaluation. And by the way, the things which I'm sharing here, if you want to get your hands dirty and try them by yourself, you can do that. The first notebooks for the first part of the presentation are already on GitHub, and the second will hopefully be coming up in the reasonable future. The data is important. In the first part of the presentation, we're relying on CMU dataset from a snapshot of Wikipedia. While this dataset is relatively tiny, it has advantages in the sense that it is simple enough to understand. It is similar to real world knowledge bases in terms of size and structure. And it comes together with pre-curated questions and answers from Carnegie Mellon students and professors, which simplifies our job in building benchmark. And why retrieval augmented generation? It's occupying, if I'm not mistaken, at least a third of current enterprise market in terms of popularity of GenAI solutions. The reason for that is its efficiency in terms of cost and adaptability. In comparison to fine-tuning of language model, where you retrain it to become an expert in a particular domain. Retrieval augmented generation is similar to a very good librarian who is, in general, comfortable with working with information from a large set of different sources, systemically processing it, extracting important pieces from it, and generalizing the answers. Unlike fine-tuning, it is not an expert in a particular domain, and that's in a sense also its advantage, because it does not rely on memory. It relies on sources, finding relevant sources that you provide to it in a knowledge base. The advantage of that is because even if it's wrong with its conclusion, it still gives you citations, and you as a human can validate the correctness of the answer and reduce the risks of hallucinations impacting your business decision. And another thing is update a knowledge base is much cheaper than retrain a language model. And with again, how quickly businesses are moving, if you go with fine-tuning, you do need to retrain your model very often. However, with RAG, you just need to update the relevant knowledge sources if they become out of date. Much cheaper. So how we look at a simple RAG model? And the interesting thing is, even a complex advanced RAG model in essence perform like that. There are some bells and whistles, but the core principles remain the same. The input is some user query which triggers retrieval of relevant information from knowledge base. A knowledge base in simple case is a database, but it may also be API to some other system which contains index of data, such as Bing Search API, or you can think of maybe ServiceNow or another system that contains some information of interest that is retrievable. Okay, so you take those retrieved pieces of information, for example, top 3 of them, then you combine them with query from the user and augment it also with guidelines to the LLM on how you want it to process it. You can tell it to be concise with the answer. You can tell it to be more creative or less creative, things like that. And then you send it to the endpoint, and then endpoint returns the results, and you give it to the user. There, like I said, there may be some additional design improvements, wrappers around these pieces, but in general, this is what RAG does. Embeddings is the mechanism that made this system recently possible. And embeddings is, in essence, just mathematical vector representation of semantic meanings of words, sentences, paragraphs, which preserves the important properties, like if semantics of a word 1 are similar to word 2, then vectors are also close in the vector space. And then mathematical properties are preserved as well. Like if you add vector woman to vector king, you will end up with vector queen. So this allows very efficient and quick operations like search, and as a result, RAG do things more efficiently than the old style keyword search, such as imagine that you have a store of toys for kids, and some parent comes looking for a bright ladybug. And there is no ladybug toy, but then they still can get top relevant result, beautiful butterfly, and maybe their child will be happy with beautiful butterfly or something like that. So basically the idea is to focus on semantics and to do it in a more efficient manner by crunching numbers instead of messing up with texts. And there are many databases that support that. Like I mentioned, Azure AI Search, Azure Cosmos DB, MongoDB, PostgreSQL. So they are different and similar depending on the criteria which you are looking for. So on case-by-case scenario, you would want to pick one or the other, but basic capabilities in terms of supporting embeddings and efficient search, they all are on par. Okay. And so now let's look at a slightly extended model of RAG. Obviously, before you are able to search in your knowledge base, you need to have it populated. And this is what happens in the part on the left, where we are pre-processing documents in order to make them consumable by AI. And by pre-processing, usually in RAG world, you deal with first chunking it into some sub portions. Then you calculate those embeddings we just discussed and just this into vector DB. And then we already went through the flow. It's just a little more detailed in the sense that before we search by a user query, we also calculate embeddings for this query, and then we can do efficient similarity search in the vector DB. And the rest is clear. So chunks, just a couple of words in metaphorical sense, you can think about them as going from parchment to a book where the information is broken into more conveniently sized pieces. They can be just broken by length, or they can be broken semantically. The idea is to make it easier for the system to fetch what's usable for the answer. And even though the context windows of language models are growing, and these days it in theory can acquire like book in one call, you don't really want to do that because similar to human, when you give too much information, it's harder to process and focus on the right piece that is important. So in this sense, even if you deal with even if you have the advantage of language model with large input size, still highly recommended to consider chunking of information if it does not fit the reasonable size of being consumed in one call. Okay, so we approached the point of being able to build a simple RAG, so I'll switch to notebook. Hopefully I will switch to notebook. There you go. So this is Microsoft Fabric interface. And I hope you're familiar with general idea. Basically, it marries the data processing capabilities with power of analytics and visualization from Power BI, which is obvious in the interface. So there is this Explorer tab where you can have your data sources, and then there is the notebook, the world of data scientist. Okay, so in this notebook, we are starting to build our RAG. I am going to be using built-in GenAI endpoints, Azure OpenAI GPT, but you can also bring your own keys. And so the only thing that I'm bringing actually is AI search as the database to insert the RAGs. And I won't be focusing too much on individual blocks of code. Like I said, they are out there on GitHub. I'll share the links. I'll just explain you the big pieces which the code does. So we start with pulling the data from an Azure Blob, and we are storing it here in the lake. And then I go with a very basic exploratory data analysis. It's not the focus of this particular little demo. So I can just eyeball pieces. I can see that there is article, there is path of the article, and there is text. This is how the text looks to me. And there are questions and answers. So questions are like, some are good questions, some are not so good questions, and answers which are curated by humans. Okay, so here we are with our data. And like we discussed, we start with chunking, for which I'm using a built-in page splitter capability of SynapseML library that comes together with Fabric. Then I'm doing explode with the help of Spark to ensure that each chunk is allocated its own row in the table. Then I do some kind of housekeeping task of adding ID to our columns so that it helps me with the next stages of ingestion. And I'm doing embeddings. Again, this is accomplished with SynapseML library in a distributed fashion with embedded OpenAI endpoints. Okay, so now we're done with that, and we want to start ingestion. Ingestion goes into Azure AI Search. This looks like slightly overwhelming piece of configuration, but the good news is for most applications, you can just copy paste it, that you don't really need to rethink it, because the fields which are created in the database are generic and domain agnostic. If you do want to play with that, the third notebook in the set actually helps you learn more about what different parameters are doing. So then I define a function called insert to AI search. It's pretty basic. The interesting thing about it is the attribute UDF is user-defined function. This is what allows you to apply a Python function to data frames in Spark. Okay, so now we are just running this function on our data frame, and we go ahead. This is very important part. After I completed the ingestion, I want to make sure that it ran successfully on all of my rows. And it's important for two reasons. One is if you accidentally failed to insert something and you proceeded without noticing that, then you test your RAG and you see that on some questions it fails. You start to blame LLM, or you may start to think like something is wrong with retrieval, but there may be a problem that is as simple as data is just not there. So we should detect that as soon as possible. And reason two, for those of you who might have worked with Spark before, it has this funny property, it is lazy. So unless it absolutely has to complete something, it will pretend to complete this, but won't do. So in this case, if I didn't do that, even though I executed the function on the row above, it won't really run on the whole data frame until it is forced to. And by asking it to compute on how many of the rows this uploads were successful and how many not, I force it to go over the whole data frame. So that's another important pattern when you work with Spark. Okay. So then we look into wrapping it into actual RAG. We have the knowledge base. Now we need to marry it with a language model. For that, we need a couple of things. First, we need a function that allows us to integrate with the knowledge base by supplying a question and number of results which we want to get out of it. So this is what this get context source function does. We'll call it retriever. And embedding is with text embedding ADA 002 model. And then let's test this function. I supply question, how do elephant communicate over long distances? And we get something back. We get search score, meaning how good the chunk matches the question. And so this is done. And then we add a get answer function. So get answer is where you give users question, you give the context fetched in previous stage, and then you give this prompt to LLM on what to do with that. And here we're doing with GPT-35, slightly outdated, but actually pretty good for this particular simple scenario. And this is where we close the loop. We run get answer with question and retrieved context, and this is what the LLM spits out. So here you go. We just built our very first RAG. It like running this notebook will take you a few minutes, but it's fully functional and something which can work as your baseline for building real application. Okay, so now let's see. We cannot call it real engineering if we just stitch something together. We need to analyze and evaluate how well it performs. And the important thing about evaluating RAG is something which is rarely explicitly recommended in the online guidelines is to separately look into its components, separately look at retriever and the response generator. Why it matters? It matters because if this piece does not perform well, if you cannot retrieve well from your knowledge base, then regardless of how advanced is your language model, your librarian won't be able to give you good answers. So you really want to strive for nearly 100% retrieval accuracy. And only then you can hope that non-deterministic by design LLM will perform good enough on your tasks. Okay. And another good part about doing it separately is because when you look at retrieval, you're able to use deterministic metrics of whether or not a particular source was fetched from the knowledge base as you expected. While when you look at the output, it is more convenient to use AI-assisted metric. You can still use the old school F1, Rouge, and Blue, but AI-assisted metrics are much more powerful because they emulate how a human would be evaluating the answers and can do things like fluency and relevance and so on. So very refined evaluations. And another important practice to keep in mind is to not just do one-off evaluation, but keep some sort of dashboard of experiments, because this allows you to see that you do not regress metric 1 while improving metric 2, and it also allows you to see your progress very clearly. Like if you are communicating to your customer on a weekly basis, you can show how like you're moving from a good to even better. Like in this case, we see that retrieval rate has improved from 77 to 98%. And I'll then explain you how that happened. And for now, let's just do a quick look at the second notebook focused on valuations. First part is very similar, except that in this one I'm using bring my own GPT endpoint, and I'm using a different flavor of GPT. So we start with creating a benchmark, and for that we take questions and answers from the subset of the data, and we filter it by medium complexity and a duplicate, because some of them are duplicate. That's how we end up with 20 pairs of questions, answers, and source identifiers. In the real life, we recommend going with about 100, because it's good balance between what a human can realistically look at when needed and being substantially large and diverse. But for the purpose of the demo, 20 is enough. So we already went over these functions before. This is the retriever and generator of answers. And we start the evaluation by just simple smoke test end to end, making sure that all of our functions work and retrieve what seems to be expected result, and that passes. And then we go to defining evaluation metrics. So here we will define one deterministic metric, the retrieval score, inspired by the way that search engines have been evaluated for a long time. And it's as simple as you compare the retrieved sources with what you plan to, what you know from the benchmark to be the real source of truth. If it's one of the retrieved sources, you give a 1, otherwise you give a 0. And then we test this function. In our case, with question about turtles, we fetched the right source indeed. And then we define AI-assisted metrics. These definitions are inspired by documentation of Azure AI Foundry with very slight modifications. I reinforced that it should produce the output in the form of just the number 1, 2, 3, 4, and 5. This is because sometimes LLM tends to be overly verbose and explain why it did this or that. So we're practically mitigating those risks. And in this prompt, you give examples of how you would want it to rate a particular input. So relevance metric checks whether generated answer aligns with the question that the user was asking. Similarity metric checks whether the generated answer is similar to ground truth answer. This is where it also checks and penalizes for differences in conciseness, for example. Like if LLM just says yes or no, and the model subject matter expert was verbose, this won't be 5. but it won't also be 1. So in our case, with turtles, we got both relevance and similarity for the answer at level 5. Great. So now we can evaluate this on the benchmark data set. And what we're doing basically is we take our benchmark, and first we start with fetching the right sources. We apply get retrieval score to that, and we display the result. Let's see. So question, retrieval score, extracted path, and retrieved sources. So retrieval score, as we see, is 1 for all rows, which is great. We accomplished great retrieval, 100%. Happy to proceed to the next stage. If it was like somewhere at 60, doesn't really make even sense to continue looking at how LLM does. And so next we apply relevance and similarity. All right, perfect. So this is our scores. A bit hard to look at every row as a human, so we will build histograms, and we see that similarity for one of the answers is not great, which is this. Let's see, this is what the human answered. Largest elephant ever recorded was shot in Angola, and then generated answer said the text provided does not specify. And we know that the text actually was retrieved correctly because retriever score is 1. So something is to be improved with how LLM is processing the text, or maybe we have too large chunks and LLM doesn't handle them well. So basically now we have narrowed it, right? Like we do know the right source is retrieved. And once we have completed the experiment, we store the results. Like I said, it's very important for future reference. Okay, awesome. So now we have discussed the basics, and let's look at the fun part. And the fun part is how fabric makes a difference, because you could have told me like, hey, Alexandra, why do we really do this in fabric and not still on the laptop, right? The reason is with naive approach, we may end up in a situation where our data is good and reasonable, and AI is functional, but they just don't work together. And so what we accomplish with the help of data platform is we can take data in whatever form it is and make it consumable by AI, retrievable, and then processable at the stage of runtime. The typical problem of modern businesses is that they run at unprecedented space, and a lot of knowledge remains tribal in employees' conversations or side notes or things like that, but not official structured public documentation. So how can AI help us deal with that situation? This is where we will dive into applying data science methods and working through huge, complex, unstructured, informal data into formal, structured knowledge. And for the purpose of the demo, I curated a hypothetical set of Teams conversations, about 1,000 discussion threads, in each about 10 responses between fictional people on different topics. So this emulates the conversations between employees in a business, and it also emulates a real use case for a project which we have been working in with Microsoft, but we cannot share this data externally. So basically, this was based on a project to help my own team work with tribal knowledge. So the way to extract most valuable pieces from large conversational data has been known for a while. It's a frequently asked question document, but it used to be built by humans. Now let's see how can we build it with AI. If you look at the individual pieces, it looks quite similar to the good old data science. We start with the DA, then we clean the data, pre-process it with embeddings, and then we do clustering. We aggregate groups of questions by similar meaning. And then for each of the clusters, we ask LLM to come up with a generalized version of the question. So at high level, this is how we approach FAQ generation. And Elgar, you're coming on camera. Does it mean I'm running out of time, or can I still keep
No,
going?
no, 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 no. You can go on. We have some time,
Good.
so good. You
Okay.
can go on.
So exploratory data analysis. The great thing is with the help of GenAI, your exploratory data analysis can be much more advanced than it was before. So this is an example of the exploratory data analysis that I ran on an actual forum of my team. So the beginning of the slide, you can see histogram of length of threads. What attracts attention is that the majority of threads are relatively small, and there is also this big spike in the beginning of very small threads. So you want to know why is that? And one big insight that hugely informed our processing was to find out that the majority of the posts in these threads contain not just one question, but two, and in some cases, even 9. So this is very helpful because it also explains to us the insight we see next. Out of conversation threads in the forum, GPT classified only about a quarter as resolved and the rest as unresolved. But that doesn't mean that they were not answered. We actually saw that the majority of posts do have answers. The problem is, like we discovered in the previous analysis, the questions are complicated. They have several sub-questions in them. And so what often happens is somebody answers part of the questions but leaves the other open, or maybe they actually do answer everything, but then person comes back and asks for clarifications or revives an old thread. So this is what typically happens. And also some statistics on the count of messages per day, on the growth of popularity of that forum. So in which sense does it help us? It helps us understand how we clean the data. We want to focus when we generate frequently asked questions on individual questions, not those like aggregated questions within one post. So how we can do that? We can break questions, break posts into individual questions, segment them out. This is probably reminding you of a popular method in RAGs called HIDE, hypothetical document embeddings method. which is known to be a very big booster of retrieval score. The essence of it is you don't operate on the raw text in the knowledge base, but you operate on how they should be retrievable, and this is also what you embed. In our case, we don't even need to ask LLM to hypothesize about the kind of questions by which to fetch this or that thread. We already have the questions. People ask them. We just need to extract individual questions and then look at them. So this works very well with very, very few exceptions. There are funny exceptions, like one I gave in this slide. In this example, GenAI got stuck in infinite loop, hallucinated a response to the thread and kept repeating it 100 times as if somebody is reinforcing what was said before them and saying very generic things about the importance of integration and migration process and so on. But this is very rare, and we detected this automatically very easily because the hallucination went so big that it exceeded the context window of LLM. But overall, it performs, I would say, at least as good as humans. So this is like our next building block. Segment, embed, and then cluster. So how we want to cluster? There are like clustering has been developed at length, but which method would be ideal? The specific of our problem is that we don't know in advance how many clusters we have. We operate on some forum and we actually want to extract how many things are there. This is where a type of clustering called hierarchical agglomerative clustering is helpful. The goodness about it is that when you build the tree of clusters, you don't need to know in advance how many subclusters there will be. But once you build it, you can try out cutting it at different levels and seeing which breakdown gives you the best idea in terms of the problem you are trying to solve. So how it works exactly? In the beginning, you have entities, and everything is considered a cluster. Then you look at the entities and find two of them which are closest to each other, and you join them. Now they will become one cluster. So you now have n-1 clusters. Now you search again for two closest clusters. It may be two individual entities, or it may be an entity and the cluster of two entities that you formed previously. So again, you join the two closest, you end up with n-2 clusters. So this is what you repeat until everything is one cluster. And then you can cut the trees at different level, and it gives you an idea of how to join your entities. Like I said, embeddings is how we operate because clustering works better on numbers. And this is how my real forum ended up being broken down by themes. So you can see, like, by coloring, some themes were very clearly outlined as dominated, some less popular. So I won't be like going into details of which themes are here, but I'll show you a demo of how this worked on my synthetic data set with hypothetical discussions. So data here is in the format of Graph API teams, and we start by converting it into a data frame. So the data frame has some metadata, and the gist of it, the texts. We start with segmentation. Like we discussed, it's important to segment the question out. We don't care about fluff like persons' names or greetings or jokes. We just want it to focus on the questions. Okay, so this is what we have done here, and then we allocate, again, expand to individual row for a question. Our data set has become about double of the original because, like I said, it's 2 questions per post. Okay, now we filter it, we shuffle it just to make it interesting because original synthetic data set is ordered by theme, and we don't want this to be kind of biasing the result. Okay, so now we are done. We are ready for clustering of the embedded themes. And look at that. Look at that. I'll stop, pause it for a while. Like I said in the beginning, there are 7 themes: cooking, embroidering, watercolor, and something like that. Chemistry, I think. And we clearly ended up with 7 potential clusters. So if I cut my tree here, I have very clearly 7 subtrees, right? But that communicates to us that clustering did the right thing, but not yet solved our problem. What we want to accomplish is to find frequently asked questions underneath each of these big themes. So let's keep going. I take higher number of clusters, 100, for the sake of this demo, and I look at, if I cut the trees at this level, what will end up in individual clusters. So it shows me text of the threads, which ended up joined within a particular cluster. Now I want to start with most popular questions. So I want to look at the biggest clusters first. And that's why I sort clusters by the number of elements inside them. And the biggest cluster had 77 elements. Okay. And so the next thing is I will give those things to LLM, and I'll ask it to aggregate and generalize meanings within individual clusters, and this completes the work, right? We have found common questions within each clusters. Remaining part is to also extract the answers, but the idea is quite the same, and you can figure out how to do it with similar patterns. So I find it really fascinating, right? Because we went from 1,000 of conversational threads to a set of 100 most popular questions in this pretty simply understandable notebook, which runs end to end in about an hour on Fabric. Isn't that cool? Okay. So how can you actually use it within your RAG? This is the blueprint of the design. This is the piece where it goes from teams to the data store. Then with Fabric, you convert the raw data into the questions and answers. And then you embed and put this into Azure Cosmos DB, and then you can use it from your agent. Like in our case, we built an agent in Teams with the help of Bot Framework, and it talks to the tribal knowledge in Cosmos DB, as well as it talks to Bing Search API. In this way, it is able to find out information from 2 sources and serve it back to the users. So that's a high-level architectural diagram of an actual system that our team built. And this is how it looks. Again, I'm showing you a demo on synthetic data, not real data. Nugget GPT was the code name for it. and we're asking it about different cooking methods, how they impact quality of food. So you can see that it returns links to previous chat history. You can click and verify, and you may also do other fascinating things with it. So this is how you can do answers. And the benchmark, very important to build benchmark. In the case of our real project, we built benchmark from actual questions in the channel, and we had the subject matter expert pick the questions, and then we had AI massage those questions, like segment them, break them into sub questions and answers, and then feed it back to subject matter expert to prune it, because we ended up with too many, like 300 questions after this processing. So we picked the best one and the most diverse set, and that's what ended up to be our benchmark. And another important thing for real world RAG is, in terms of evaluations, like specific to this case study, especially, is you may end up with multiple sources of truth. For example, some of the themes may be discussed not only in the Teams conversations, but also in the documentation. And in this sense, we are suggesting to use a metric called semantic coverage score that works as a proxy of retrieval success, regardless from where the retrieved information came from. This is what helps us deal with data drift in time and multiple and vanishing sources of truth. And here I'm showing you experimental results on this real project. As you can see, we started well because we knew the secret sauce of embedding questions instead of embedding the whole raw data. And we ended with a strong retrieval score of around 90. So conclusion, adaptive knowledge base is a very powerful pattern for building a RAG for your business. You can use it both to build a static FAQ file that can be automatically updated, and you can use it in your RAG for real-time Q&A. And so in terms of evaluation, which is the core part of RAG engineering, they also help each other. So this is the biggest takeaway pattern, which I hope you learn in that presentation. And unified data culture is becoming more and more important. Oops, sorry, unplanned music. Yeah, that concludes the presentation. If you would like to dive deeper, there are some good online resources that are authored by myself and my colleagues. And I would like to acknowledge my awesome team, without who all of that would not be possible. And time for your questions.
Thank you very much, Alexandra. By the way, will you be so kind as to copy and paste these links in chat box?
Yes.
Would be great. And of course, if there is any question, please ask a question. But I would like to ask two questions. First one is, does Microsoft Fabric documentation cover information about RAG?
It is in GitHub currently, official Fabric GitHub. So I would suggest that you go there. But we also work on, oh, it's too much. I need to insert in chunks. We also work on including this documentation in MSLearn.
To be honest, I couldn't find related information in Microsoft Fabric documentation. So
Yeah,
that I,
because it's on
yeah,
GitHub. Yeah, I guess you were looking at MSLearn.
okay. And one question related to Power BI and RAG. So, how can Power BI be used to monitor and visualize the performance of a retrieval augmented generation pipeline built in Microsoft Fabric?
Yeah, pretty much in the way that you are comfortable with. So the diagrams which I shared in this demo, I built with Python just because as a data scientist, I'm comfortable with that. But at the end of it, I ingested the results of all experiments into the Lakehouse. And Lakehouse is exactly the integration point between the notebook and the Power BI visualization semantic model. So you can just pick it up from there and seamlessly update whenever new experimental results are posted. And that's one way. Another way is like, say you have a multi-agent system and there is ongoing telemetry flowing into, say, Custo database, right? And then you can visualize this telemetry again in the dashboards, depending on also business views of people with who you work, whether it's like management or your site reliability engineers team or your dev team or your user experience researchers. You would slice by different dimensions and metrics of interest.
Thank you very much. I highly appreciate your time, your desire, I mean, sharing your knowledge, experience, skills with us. So I hope there is no question. So with your permission, I would like to stop streaming. And yeah, there are some thank you messages. Okay. It's actually high level topic. So I understand. But anyway, yeah. And by the way, will be there an opportunity to share the uh, presentation in PDF format, or it's not subject to sharing?
No, this is the content which I covered here is not confidential. I cleared
Okay.
all the confidential pieces of it, so I'm happy to give it to the attendees. Just don't like don't distribute it publicly. Just keep it like within the group for your own.
So, yeah, if you share with me via email, I will also in my turn will share with
Yeah,
attendees.
yeah.
So, okay, once again, I'm just going to stop sharing. Thank you very much. I stopped sharing. I'm streaming. So, if there is no question,